Good day, students. How are you doing? This is me again, Sir Navarro, and welcome to our part 2 of solving problems involving quadratic equation. So, this is example number 3. A children's park is 350 meters long and 200 meters wide. It is surrounded by a pathway of uniform width. Suppose the total area of the park and with the pathway is 74,464 square meters. Question is, how wide is the pathway? So it's so obvious. The question is asking for, the problem is asking for the wideness or the width of the pathway. Okay, so again, the same step. We read the problem and then um, we already have we already have the original piece, right? Which is the 350 and 200 meters by 200 meters, the rectangular part, of course. So now here is the illustration of the given. So basically the first this is the original dimension, right? So this is 350 and then this one is 200. Okay, so if you noticed, this one is in the inner section. Okay, so it is also stated in the problem that there is a pathway that surrounds the playground or the park. Okay, so we know that the children's park is 350 meters long and 200 meters wide, and with that we let x as the width of the pathway or the wideness of the pathway. So with that we can say that with the original length, and then we add the pathway along here, right? Because if you notice, this is if we add an x here on this part, and we also have an x on this side because it's talking about equal size, equal length pathway. So basically this is the illustration. So with the 350 you have to add 2x, okay, because there are two length or two length of or width of pathway here. So basically that is 350 plus 2x, because you're not only adding x on this side but on both sides, right? Both ends, not side, both ends. So 350 plus 2x. Okay, now same with 200. So the original width is 200, so including the pathway, the width is x. You also have to include the other end. So x plus x is 2x. This is now your new dimension, 350 plus 2x and 200 plus 2x. The pathway is formed by adding x meters, right? X plus x on both length and width on every end of it. Okay, so now we write the equation. The formula for the area of rectangle is a equal to length times width. So there we substitute them. So the area given is 74,464, and then the length is this. The length that we're going to use is the new one, including the pathway. So we have 350 plus 2x, and then the width is 200 plus 2x. So basically, if same constraints, okay, note that the dimension of the park must be positive numbers. Okay, so basically this x should be greater than these two constraints here doesn't matter because these are very far numbers. So you can also have it to shorten the constraints. No? You can have it this one, since we're talking about a positive number, so we have to say that x should be greater than 0. Okay, so this equation will be satisfied if this is x is greater than 0. Okay, so now we solve for the equation. So this is the original equation, and then if you do the FOIL method with that, This is our first 70,000 outer. This is 700x. Inner, we have 400x. Last, we have 4x squared. And then if we rearrange and combine like terms, we have 4x squared plus 1100x or 1100x plus 70,000. Then to simplify more, we subtract we subtract 74,464 on both sides. Then simplify, this becomes 0. And this one, just copy the two terms here, this one and this one. Then you subtract this 2, you'll be given, the result is negative 4,464. So now, this equation can be reduced, right? There is something in common. They have something in common, which is 4. So we divide all the terms by 4, which gives us the final answer of x squared plus 275x minus 1116. So we have here, to solve for the equation, we use the quadratic formula. Okay, our a is 1, b is 275, c is negative 1116. So by quadratic formula, we simply substitute it here. Okay, these are the values. So negative 275 plus or minus square root of 275 square minus 4 times 1 minus 1116 all over 2 times 1, which is negative 275 plus or minus square root of 75,625 plus 4,464 all over 2. And then if you add the radical, it will give you 80,089. And square root of 80,089 is 283. Okay, so 283 is and then if we separate the plus from minus, we'll have this. So this is the plus. If you add them together, you will be given 8 over 2. 8 over 2, or the sum of the numerator is 8, and then over 2 is 4, right? It's 4. And then in the other side, we have negative 275 minus 283, it's negative 558. Divided by 2, we have negative 279. So again, we don't use the length or width whose measurement is negative, right? Negative. So basically, we stay with positive. So x is equal to 4. So state the answer. Only 4 satisfies the restriction that x is greater than 0. It should be positive. So thus, the pathway of the children's park is 4 meters wide. Okay, 4 meters wide. Now, to do the checking, the length of the children's park is 350 plus 2x, right? So 350 plus 2 times 4, which is 8. We add them to 358. So the width is 200 plus 2x. We have 200 plus 2 times 4, which is also 8, 208. And if we multiply the two, 358 times 208, we have 74,460. So the pathway is 4 meters wide. Okay, so now let's have another problem, which is all about using Pythagorean theorem. So Pythagorean theorem from geometry is used in example 2. It's used in example number 4. Okay, so it's used in example number 4. So basically, Pythagorean theorem states that two sides that meet at the right angle are the legs, and the side opposite the right angle is the hypotenuse. Okay, so these are the two sides that meet at the right angle, and then the side opposite of the right angle is the hypotenuse. So what is Pythagorean theorem? So a Pythagorean theorem, according to Pythagoras, the sum of the sum of the squares of the lengths, which is a and b, a square and b square, is equal to the square of the length of the hypotenuse. Okay, so a square plus b square is equal to c square. So that's Pythagorean theorem. So now let's apply it to this problem. So Eric van Erden finds a piece of property in the shape of a right triangle. he finds that the longer the longer leg is 20 meter longer than twice the length of the shorter leg. So if you notice, this part here is quite somewhat like confusing, but yeah, we will try to operate on that later. So let's continue. The hypotenuse is 10 meters longer than the length of the longer leg. So find the lengths of the sides of the triangular lap. So here the longer leg is more or less dependent on the measurement or the representation of the shorter leg. So basically, we have to represent first the shorter leg so that we can represent the longer leg. So it's the same with hypotenuse. After identifying the representation of the longer leg, we can now represent the hypotenuse. Okay, so the problem is asking for the lengths of the side of the triangular lap. So yeah, next is we must find the lengths of the three sides. So first is we have to, so just like what I've said earlier, we have to assign variable. So again, I'd like to reiterate that the length of the longer leg is dependent on the representation of the longer leg is dependent on the representation of the shorter leg. And the representation of the hypotenuse is dependent on the representation of the longer leg. So if we represent shorter leg as S, okay, in meters, then we can say that the length of the longer leg, so we represent the length of the shorter leg as S in meters, and then now we can say that the longer leg representation is divides it was said here, the longer leg is 20 meter longer than twice the length of the shorter. So twice the length of the shorter is 2s, and longer 20 meters longer, so we add 20. And the length of the hypotenuse is here, hypotenuse is 10 meters longer than the length of the longer leg. So the hypotenuse is represented as this one. This is the length of the longer leg, right? Longer leg, LL, and then added, or because it says there that it's more than 10 meters more than the length of the longer leg. So basically we have to add 10. And then if we simplify that, we have 2s plus 30. Okay, so this is now our hypotenuse. This is now our longer leg, and this is our shorter leg. So the length of the hypotenuse is 2s plus 30. Okay, this is now the representation. So this is the shorter s, longer leg is 2s plus 20, and the hypotenuse is 2s plus 30. So we write the equation. This is a squared plus b squared equal to c squared. So this is now our a, which is s squared, and b is 2s plus 20 squared. So our c, which is the hypotenuse, is 2s plus 30 squared. Okay, so do not interchange the values of the a, b, and c. So now we simplify each group. So this is a perfect square trinomial. If you try to simplify this, you have the pattern. Remember the pattern of the PST. Square the first term, twice the product of the first term and the second term, and then square the last term. Same goes on the other side of the equation, PST. Okay, always remember the PST. Now, we simplify them. We have s squared minus 40s minus 500. And then we factor 500, whose sum is negative 40. We have negative 50 and positive 10. And then s minus 50 is equal to 0, and s plus 10 equal to negative 10. So you have to use the positive, so therefore we neglect the negative, so therefore we have to use s as 50. And then state the answer. So s represents the length of the shorter, so s shorter is 50, longer is 2 times 50 plus 20 is 120, and then the hypotenuse is 2 times 50 plus 30 is 100. Okay, so now you can do the checking. If you try to use the formula, it will be